Hey guys, welcome to another video. In this video I'll be going over a paper I've put together made up of past edexcel exam questions on the topic of geometry and shape. I did a video similar to this one on the topic of algebra and a lot of people seem to find that useful, so I thought I'd do one on geometry. So if you're looking to revise geometry questions in particular, this is the video for you. I'll link the paper in the description along with worked solutions. So if you don't want to watch the whole video, you can just download the paper, have a go, and then download the work solutions. And also just to note that there are some non-calculated questions in this paper which I've marked with an asterisk. So for example, question 3 is a non-calculated question, so I'll put a little asterisk there. So just keep that in mind if you're downloading this paper and having a go yourself, that some questions are non-calculated questions. And I think that was everything, so let's get straight into the questions. Question 1 gives us a grid with a shape inside it, and part A says rotate shape S 90 degree clockwise, center 5, 4. Label your image T. So let's firstly find the center at 5, 4, so that's going to be here. And then we need to rotate this shape S around that point 90 degrees clockwise. Now you might remember in year 7 you would do, or year 8 you do this with tracing paper, and of course you can do it without tracing paper. One way that I find easy is just to look at one point on the shape and think of this point as 2 lengths from the center. So it is 3 left and 2 up, and now you need to move that L shape 90 degrees around the center. So that L shape that I've drawn is going to end up here. And so that point that I've drawn is going to end up there. That's just one way to picture it. If you have your own method of rotating shapes around a point, then that's fine too. So I've got one point here. If I look at this point, then I can draw another little L, and that needs to go 90 degrees clockwise, and it's going to end up here. So I've rotated 2 points, and then the last one I can do the same thing, and that L shape is going to end up here. Okay, so rub all of that out and now join those vertices up with straight lines, and we've got our new rotated shape, which we need to label T. Part B says describe fully the single transformation that will map shape T onto shape S. All we really need to do for that is the opposite of what we did in part A. So we need to rotate the shape back anti-clockwise. So the single transformation will be to rotate 90 degrees anti-clockwise around center 5, 4. So that was question 1 for 3 marks. Question 2 says Eric and Geraldine both drove from town A to town B, and here they give us a diagram, and it says both Eric and Geraldine left town A at 2 p.m. Eric drove on route 1, he got to town B at 2:48 p.m. Geraldine drove on route 2, she got to town B at 3:25 p.m. Who drove at a greater average speed? You must show all your working. So this is a speed, distance, time question, and we need to find the average speed of both Eric and Geraldine to decide who drove faster. So let's start with Eric, and the first thing we need to state is how long it took him. So Eric's time, well, he left at 2 and he arrived at 2:48 p.m, so it must be 48 minutes. And because we want an average speed, usually we say average speeds in terms of miles per hour. So we want this time in hours. To convert that to hours, we divide it by 60. 48 divided by 60 is 0.8 hours. And then we can say his average speed is distance over time. And he has traveled, now we need to look at the diagram here, he has traveled 36.4 miles on route 1. So his distance is 36.4. His time is 0.8. So we can put that into a calculator. 36.4 divided by 0.8, and that gives us 45.5, and that will be in miles per hour. So that was Eric's average speed. Now let's look at Geraldine's time and average speed. So her time, well, she left at 2 p.m. and she arrived at 3:25 p.m. So her time must be 1 hour and 25 minutes. And again, we want to convert that into just hours. So we could say that's 85 minutes in total. So we need to divide 85 by 60. And I'm just going to leave this as a fraction, a simplified fraction. If you put that into a calculator or you simplify it, you get 17/12 hours. That's just my own preference. If you wanted to write that as a decimal, that would be perfectly fine as well. So her average speed will equal distance over time again, and she has travelled 65.2 miles. So that's Geraldine's distance. Divide that by 17/12 and we'll get her average speed. So let's go ahead and do that in a calculator. 75.2 divided by 17/12, and that's going to equal 46.02 approximately, 46.02 rounded off, and that's in miles per hour as well. Okay, so we have an average speed for Eric and an average speed for Geraldine, and we can see Geraldine's average speed is clearly greater than Eric's, so we can say therefore Geraldine drove at a greater average speed. And that's question 2 for 3 marks. Question 3 is a non-calculated question, and it says the diagram shows a fish tank in the shape of a cuboid. The dimensions of the tank are 50 centimeters by 32 centimeters by 20 centimeters. The tank is 3/4 full of water and sand. The ratio of the volume of water to the volume of sand is 5:1. Work out the number of liters of water in the tank. You must show all of your working. So the way I approached this problem was to first find the total volume of the tank. So we can do that just by multiplying the dimensions together. So we've got 50 times 20 times 32, and 50 times 20, that's 1000, times 32, 32 times 1000, that's 32,000, and it's 3/4 full of water and sand. So the volume of water and sand altogether is going to be 3/4 of 32. Well, if we think of 32 divided by 4 times 3, 32 divided by 4, that's 8, times 3, that's 24. So altogether, the volume of sand and water is 24,000. And we also know the ratio of sand to water is 5:1. So in total there, we have 6 parts. So you can think of this as 6 parts of the ratio. And so therefore, 1 part will equal 24,000 divided by 6. 24 divided by 6, that's 4. So 1 part will be 4,000 centimeters cubed. And we want to work out the amount of water in the tank, which was 5 parts of this ratio. So we want 5 parts, and we can multiply that by 5. 4 times 5 is 20. So there's 5 parts of water, which is 20,000 cubic centimeters. And now you need to know how to convert centimeters cubed to liters. So the general rule is that 1000 centimeters cubed equals 1 liter of water. And now if you have some kind of mathematical OCD, you would recognize that water doesn't always have the same density, so this isn't always actually completely true. And this has been recognized by mathematicians about 50 years ago, but we still use it as a general way of converting volume to liters. So it's still acceptable when answering exam questions, so we can say that the amount of water we have is going to be 20 liters. So 20,000 divided by 1000 gives us 20 liters. And that was question 3 for 5 marks. Question 4 says, here's an accurate scale drawing of a school playground. 1 centimeter represents 2 meters. Nassim is going to put a seat in the playground. The seat has to be less than 9 meters from C, closer to BC than AB, and more than 4 meters from AB. Show by shading on the diagram the region where Nassim can put the seat. So we have 3 criteria to fulfill here, and you should have a compass. I can't get a compass in this software, so unfortunately I have to use a protractor for this. Please don't do this in the exam. Obviously, if you had a compass, set the length of the compass to 4.5 centimeters because the scale is 1 centimeter for 2 meters. So we need to divide that length by 2 to get our measurement in the diagram. So set your compass to 4.5 centimeters and draw a circle around C. And also I struggled getting the scale correct in my diagram, so it may look different to this. Obviously on your paper the scale will be correct, but in this software I was struggling to get that correct. But anyway, you get the point hopefully, that you draw a circle with a compass around C to represent this, less than 9 meters from C. Then we also need a line closer to BC than AB, and that needs a diagonal line bisecting the rectangle from B to D. So go ahead and take your ruler and draw in a straight line from B to D. And again, I can't get that completely accurate, but it should go through both angles exactly and cut them in half. So anywhere in this triangle we will be closer to BC than AD. And the last point says more than 4 meters from AB. And on our scale, 4 meters will be 2 centimeters. So again, we need our ruler. Go ahead and measure 2 centimeters away from A. So one way to do this is to make 2 marks on the edges of the rectangle at 2 centimeters, and then rule the line between those. So rule a straight line, and that's a horizontal line 2 centimeters away from AB. And now we need to shade the region that satisfies all of those 3 criteria. So it needs to be less than 9 meters from C, so that's inside the circle, closer to BC, that's inside this triangle here, and more than 4 meters away from AB, and that's below this line. So the area we need to shade will be in here. And as I said at the start, your diagram might not look exactly the same because I didn't get the scale quite right in this, but hopefully it looks similar to this diagram in that you've got a circle, a diagonal and a horizontal line, and you've shaded this region in the corner here. And that's question 4 for 4 marks. Question 5 says here are 2 rectangles. All measurements are in centimeters. The area of rectangle A is equal to the area of rectangle B. Work out the perimeter of rectangle B. So because we know the areas are equal, we can say that these 2 sides multiplied together equals these 2 sides multiplied together. So that's how you find the area of a rectangle. So we can say that 4x times 2.5 equals 7 times 2x minus 3. And we can use that to go ahead and solve for x. So 2.5 times 4, that's 10. So on the left we have 10x, and if we expand these out we get 14x minus 21. And what I would do here is to add that 21 to the left and minus that 10x from the right hand side. So what we end up with is 4x equal to 21. And I'm going to leave that there for now. So we have an expression for x, and we need to work out the perimeter of rectangle B. So that's going to be this side multiplied by 2 plus this side multiplied by 2. So the perimeter of B is going to be 2 times 7, the length, plus 2 times the width, 2x minus 3. and so that's going to be 14, and if we expand these out we get 4x minus 6, and we have an expression for 4x which is 21, so if we substitute 21 into this expression we get 14 plus 21 minus 6, and that equals 29. So the answer for the perimeter of B is 29 centimeters. And that's question 5 for 5 marks. Question 6 is a non-calculated question, and it says, here is a kite. All the angles are measured in degrees. Work out the value of y. And the key point you need to know about a kite is that opposite angles are equal. So it's similar to the last question in that we can make two expressions equal based on the diagram. So firstly, I would state that opposite angles in a kite are equal. So therefore, we can say that 3x plus 10, this angle up here, equals 5x minus 10. And if we go ahead and solve this for x, we'll get 3x plus 10 equals 5x minus 50. And then subtract 3x from the right, add 50 to the left-hand side, we get 60 equals 2x, and so therefore x must equal 30. And if we take that value for x, substitute it into either of these angles, substitute it into this one, 3 times 30 plus 10, that's 100. So this is 100 degrees, and so therefore this one must also be 100 degrees. And we can say another key point is that angles in a quadrilateral add up to 360 degrees. So therefore, these two angles added together plus this angle plus y must equal 360. So 100 plus 100, that's 200, plus 110. Let's go ahead and write some of this down. 200 plus 110 plus y equals 360. And so y is going to be 360 minus 310, which is 50 degrees. So we get y equal to 50 degrees for our final answer. That's question 6 for 4 marks. Question 7 is another non-calculated question, and it gives us a diagram, and it says A, B, C, D, E, F, G, H is a regular octagon. ADJ is a straight line. Angle BAD equals angle CDA. So angle BAD is in here, and angle CDA is in here. And it says show that angle CDJ equals 135 degrees. So CDJ is in here. So that's the angle we're looking for. So the first step here is to find out what the angles in a regular octagon equal. And for that we can use the formula for interior angles of a polygon. And that looks like this, n minus 2 times 180 divided by n. And I've done a video on that if you're not sure about that formula. But n stands for the number of sides in the polygon here, so we substitute 8 in for n, so we get 8 minus 2 times 180 divided by 8. And so that's going to be 6 times 180, and we have to do this without a calculator, remember, so 6 times 180, that's 0, 48, carry the 4, 1 times 6 is 6 plus 4, that's 10. And then we need to do 1080 divided by 8. So 8 goes into 10 once, carry the 2, 8 into 28, that's 3, carry the 4, and 8 into 40 goes 5 times. So all of this, we've done 6 times 180, which is 1080, divided by 8 is 135 degrees. And that's the interior angles of a polygon. Sorry, interior angles of an octagon, not a polygon. And so we have what each angle in this octagon equals, and because this is a quadrilateral, we can say that the angles in A, B, C, D, this trapezium here, must equal 360. So angles in A, B, C, D equals 360 degrees, and also because these two angles and these two angles are equal, we can say angle BAD plus angle CDA plus these two angles up here, they're both 135. So together they make 270. So we can say plus 270 equals 360. So these added together equals 360 minus 270, which is 90 degrees. So as they're equal, as angle BAD equals angle CDA, both equal 45 degrees. And so now I know this angle must be 45 degrees, and I can use the angles on a straight line to say that these two angles, angle CDA plus CDJ, must equal 180 degrees. So angle CDA plus angle CDJ equals 180 degrees. And so therefore angle CDJ equals 180 minus 45. So therefore CDJ equals 135 degrees. And that's what we had to show. And that was question 7 for 4 marks. Question 8 says the diagram shows a quadrilateral JKLM. Work out the size of angle KLM. Give your answer correct to 3 significant figures. So angle KLM is in here. And the first step to finding angle KLM is to find this length in here of this triangle. So because we're given these two sides, we can use Pythagoras' theorem to find the hypotenuse of this triangle up here. So we can say side KM equals the square root of 7 squared plus 4.5 squared. And this is a calculator question, so let's whack that straight into a calculator. And we can say that the square root of 7 squared plus 4.5 squared equals, and you might get an answer like that, just press the SD button to get a decimal. That's going to be 8.322 approximately, rounded off, centimeters. And now we have this length. We can use the trigonometric ratios to find the angle in here. So I might just draw this triangle in a different orientation. So if we draw it like this, it just might be easier to see what I'm explaining. So this is a right angle triangle. This is K down here, M over here, and L up here. So I've just flipped this triangle around, and we have the hypotenuse, which is 15. And we have side KM, which is 8.322, and we're looking for this angle in here. So we can say that the sine of that angle is the opposite side over the hypotenuse, and that will allow us to solve for that angle. So we can say that the sine of theta, the angle we're looking for, is opposite side over the hypotenuse. So the opposite side is 8.322, the hypotenuse is 15, so the angle is going to be the inverse sine of 8.322 divided by 15. And again, we can put that straight into a calculator. So the inverse sine is always above the sine number, or usually. And actually let's use the answer key to get this as accurate as possible. So the answer from the previous calculation divided by 15 equals 33.695, 33.695 approximately. And we need that to 3 significant figures. So these are the first 3 significant figures, and we need to round the 6 up because the next number is a 9. So this is going to be approximately 33.7 degrees. And that is question 8 for 4 marks. Question 9 says, in the diagram ABC and DEFG are parallel lines, so they're those two. Angle ABE equals X degrees, EB equals EF, that's also marked in. Show that W equals 90 plus a half X. Give a reason for each stage of your working. Okay, so where to start with this one? Well, the first thing I'd note is that these two angles in this triangle are equal because this is an isosceles triangle. So base angles in an isosceles triangle triangles are equal, and that's going to allow us to relate W to X. But just before we go into that, let's firstly state what this angle in here is, BFE. So angle BFE we can see must equal 180 minus W because that angle is on a straight line. And so therefore this angle up here must also equal 180 minus W because, as I said, base angles in an isosceles triangle. So actually I'd state that first EBF is isosceles, so therefore angle BFE equals angle EBF. So therefore angle EBF equals 180 minus W. Also, this angle in here, BEF, equals X, because these two angles are alternate. If you're not sure about angles in parallel lines, I've done a video on parallel lines if you want to check that out. So we can say angle BEF equals X, and the reason there is they are alternate angles. And now we can say, we've said this is X, we've said this angle up here is 180 minus W, and you could use angles in a triangle adding up to 180 to relate the W and X, but I'm going to use the exterior angle of a triangle rule, which says the exterior angle of a triangle adds up to the two opposite interior angles. So I know that therefore X plus 180 minus W equals W, the exterior angle, and the rule there is exterior angles of a triangle. And then I can go ahead and simplify this. First thing, add that W to the other side. So X plus 180 equals 2W. And just flip it around so I get the W on the left. 2W equals 180 plus X. And then divide everything by 2. So W equals 90 plus a half X. And we have shown what they wanted us to show. So that's my final answer for question 9 for 4 marks. Question 10 says the vector AB equals 3, 2, and the vector BC equals minus 1, 4. Vector AB is shown on the grid. Part A says on the grid draw vector BC. So we have this vector minus 1, 4. So the minus 1 is the horizontal movement. So we need to go from B minus 1 to the left, and 4 is the vertical movement, and a positive 4 means we need to go up 4. So we need to go left 1 and up 4, and that will be C. And so BC is this line here. Then part B says AD equals AB minus BC. On the grid, mark with a cross the position of D, label this point D. So one way you could do this is to subtract the two vectors. So 3 minus minus 1, that's 4, and 2 minus 4, that's minus 2. Or you could do it graphically and use this and use the negative of this vector to get D. Either way will work, so I'm just going to use this vector by subtracting the 2. So I need to go 4 across from A and 2 down to get D. So 4 across and 2 down will give me this point here, and I need to label that D for 2 marks.